Man, everything's boring. When I speak, there's no split screen Subway Surfers or cool lights going on. Maybe this is a me problem, and I should reflect on myself, maybe read a bit, meditate. Nope! I'll make any noise into light so that my monkey brain gets happy. Alright, what's up guys? I'm Terrence, and this is my solution to constant understimulation in day-to-day life. It takes the audio from around it, it gets the frequency data, and displays it on this LED matrix. If I make a high noise, this side will light up, and if I make a low noise, this side will light up. So now, I can be stimulated with a little eye candy whenever I say, play drums, do homework, bro, what is an if statement, or even nap. So how did I get here? So that looks like a lot of components, but it's really just these three. We have a microphone, a microcontroller, and an LED matrix. The microphone is gonna hear audio around it and send that data over to the microcontroller, which will then parse the data and apply an algorithm to get the frequencies of the sound. Then it's gonna give instructions to the LED matrix on how to light up. So our first step is to get audio data from the microphone. Now we need to write some software in order to get voltages sent by this to make sense to our microcontroller. Psych! Already did it all. So as you can see, it's reacting to my voice when I speak, and when I don't. So now we got the microphone talking to the microcontroller. We need to apply an algorithm to get the component frequencies and later to display onto the LED screen. So the algorithm we're gonna use is this. Yeah, is it cooked, bro? What is this? Oh, okay, well good thing there's pseudocode right here for me to just copy and implement. And boom. So we got this thing working. Using the pseudocode on Wikipedia, it wasn't hugely difficult to get the algorithm itself working. The hard part was getting it to interact nicely with the gather audio data task. To explain the issue I have, I'm gonna use an analogy. Imagine we have a bathroom and two people that have very bad bowel issues, Mr. Audio Data and Mr. FFT. Mr. Audio Data's only goal is to go into the bathroom and to populate this notebook with audio data. And then Mr. FFT, his only goal in life is to go in, read the notebook, and perform his calculations. Let's play this out. Mr. Audio Data goes in, populates the notebook with audio data, no issues, and then walks out. And then Mr. FFT goes in and reads the data and does his calculations. An issue is that Mr. FFT is much slower at his job than Mr. Audio Data is his job, just because it's much harder. While Mr. FFT is still working, Mr. Audio Data walks in and tries to change the data. That did not turn out well. Now Mr. Audio Data is traumatized and Mr. FFT is angry that his data changed while he was working and it got corrupted. The way we solve this is by having a lock on the bathroom, or in computer operating systems terms, a mutex. When audio data goes in, he locks the door behind him, populates the audio data, unlocks the door, and leaves. Same with the FFT. So he goes in, locks the door. While he's working, Mr. Audio Data cannot disturb him. And then he unlocks and leaves so that each task finishes what they're doing before the other one interferes with their shared resource. And everyone's happy. Alright, so now that we implemented a mutex into our system, everything's working great. We have a very, very robust and foolproof system. I freaking hate this thing. The gathering audio data and the FFT tasks only took about a week or two, but this was the bulk of my struggles. I tried everything to get this to light up. How can I be overstimulated if my thing doesn't light up? I rewired it probably around 15 times. I used a reputable library, but it wasn't until I actually read the description of the thing I got. Oh. The problem is twofold. Our LED matrix requires a 5-volt connection as well as around 4 amps if it's running full brightness. So our ESP32 only supplies 3.3 volts at around 30 milliamps at best. It's not nearly strong enough to power this. So our solution is
a few moments later.
okay. So now I have a fully functioning 600-watt power supply. Now let's get to the real meat and potatoes of the project. We're gonna get the FFT data on the LED matrix. Guess what? What? It's working! Hey, look at this, look at this. Boom, 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 boom. All right, now we got pixel flashing. We can go from this to this. Hi guys, Editing Terrence here. I've come to realize that I didn't adequately explain the jump from pixel to working audio visualizer. So quick explanation right here. Alright, the way our FFT outputs its data is through just a list of numbers. This is the amplitude of the first frequency bin, so this could be from 0 to 20 hertz. And then this one is 20 to 40 hertz. So a slightly higher frequency, and then 40 to 60, 60 to 80 hertz. The way our algorithm works to decide which pixels light up is it goes row by row, because that's how the LED matrix updates. We start with the bottom row. So this is row 1. What we do is we go column by column, seeing if the row number in that column is greater than or equal to the value in that spot. Let me just go through this simple example. Row 1, we start here. We see row 1 is greater than or equal to the number inside of this column. So we light it up, that's correct. And then we see row 1, column 2. Column 2 of our data is 3, which is definitely greater than row 1. So we light that up. Same with 4, and same with 2. Perfect, so we lit up the bottom row. Our next row is the second row. 1 is not greater than row 2. In the first column. So we do not highlight this. 3 is greater than 2, and that corresponds to the second column. So we go here, as is 4, and 2 is equal to 2, so we light it up. Next we go to our third column. So 1 is definitely not greater than 3, 3 is equal to 3, 4 is greater than 3, and 2 is less than. And for our last one, column 4, only 4 is greater than. This is essentially how we update our LED matrix. We have this running 60 times a second, and it looks like a fully functioning audio visualizer. Alright, now back to the video. I can be visually stimulated whenever I do anything. Yeah. Alright, so that's a project. There's a lot of technical details that I, of course, couldn't get to in this relatively short time frame, but I would encourage you guys to look at the Git repository I have in the description. It contains all the source code and even instructions on how you can make one for yourself. Thank you guys so much for watching. Bye-bye.